One to Knox Game Design for January 2025. My name is Levi Smith. So this month I'm going to be talking about implementing a drag and drop interface for games. So last month I did a simple demo of a solitaire game, so it would be possible to use this to be able to implement drag and drop for that solitaire game. So this is the basics of implementing a drag and drop interface, and I'm going to show demos and a few different game development environments. So first of all, you're going to have a pointer. Traditionally, that has always been a mouse click, but that could also be a press on a mobile device. So first thing when you're going to do is check for a click on the object. So you're going to check for a pointer down event. That's going to give you an X and Y coordinate, which is just two integers. Your object is going to have, and we're just talking about 2D, it's going to have an X and Y position and also a width and a height. So if you look at, there's our basic condition we're going to use throughout all the examples. So if your pointer X coordinate is greater than or equal to the object's X coordinate, and if the pointer's X coordinate is less than the object's X coordinate plus the object width, and the pointer Y coordinate is greater than or equal to the object Y coordinate, and the pointer Y coordinate is less than the object Y position plus the object height, then you know that click is on that object. And we're just talking about rectangles here. One thing you want to watch out for is whenever you click on an item, you also want to store the offset, the distance between where the mouse was clicked on the item and the actual item's X and Y location, because if you don't do that, you'll see some jumping of that object. And also your object will need to have an isDragged boolean to record whether or not it's currently in the drag state. And whenever it is being dragged, you'll want to move that object to the pointer position, the X and Y position minus the offset X and Y. Or if you store the offset as a negative value, then I think what I've done in a lot of these examples, you just add the offset X and Y. So here's the state diagram that we're going to use for all of the examples. So starting out here on the left, our isDrag state is going to be false, which is just a boolean. When the pointer is pressed and it's clicked, then our isDrag state is going to turn to true, and then we're going to store the offset as the position of that object minus the pointer position. As the pointer is held down, then we're going to set the position to the pointer position plus the offset, and you'll see that just keeps looping back around to that state until the pointer goes back up. The mouse is released, or the person lifts their finger off the device. So here's our basic states. And first example I'm going to do is in Unity. So you just need to be aware of the different states of the mouse. There's one event called get mouse button. And that just means that the mouse is, you can either get whether the mouse is down or up on that frame. So it's going to keep returning that same value, whether it's down or up, for every frame in our update. Then you have get mouse button down and get mouse button up. And those are only fired on one frame, the frame that the mouse goes down or the pointer goes down, or from get mouse button up, the frame that it was released. So what I said here, I suggest using get mouse button down for the press. You check the frame that was pressed, and only that frame, and then you can use get mouse button equals false for release. The reason for that is like the mouse pointer could have been released outside the game area, and the get mouse button up will never return true. And in that case, sometimes it looks like the object will stick to the mouse cursor. So here's the code for Unity right here. Here's our card object. It's all just one file. So basically a card has a width and height, which is just two integers. And then we have a boolean True or false, is dragged, whether the card is dragged or not. Then we're also storing a vector 2, x and y coordinate for the drag offset. In our start, basically we're just setting the width and height of the object, the card, using the transform, rect transform dot size dot delta x, and rect transform size dot delta y. We're initially setting is dragged to false. Here's our 3 mouse states. We got input, get mouse button down, and then passing the zero. The zero here just means it's the left mouse click. If that's the case, then we're going to call pointer pressed and pass in the mouse coordinates. If the input.getMouseButton.0 means that the mouse is being held down, left button is being held down, then we're going to call pointer down and pass in the mouse coordinates, just doing this for consistency through all 3 functions. Then if it's not input get mouse button 0, which means the left mouse button is not being dragged, then we're going to call pointer up and again pass in the mouse position just for consistency. Here's our pointer pressed method right here. We're passing in the coordinates and calling check pressed with the mouse pressed or pointer pressed location. Check pressed is basically what I showed earlier with the 4 conditions that have to be met for the x and y coordinate to click inside the object. If all those are true, then we're going to start drag. We're going to pass in the offset, which is the transform position of the object minus the pointer position. That's the offset. For the pointer up, we're going to stop drag. We got our stop drag method right here. We're just going to set is drag to false. And then for pointer down, if the object is being dragged, then we're going to update the transform position of the object to the mouse position plus the drag offset. This is what it looks like. Oh, there's the one other thing, and I mentioned it on the next slide. Here's what it looks like. I'll show the example in a second. But you do need to set some of these coordinates, especially the anchor values or the pivot property. You need to set it to x0, y0 to be the lower left, or else it has problems because the default is x.5 and y.5, which is the center of the object. You could use this, but you'll need to subtract off 0.5 size from the calculations, so it's easier to set it to 0, 0. Also, I made a note, you can use direct transform, size delta x and size delta dot y to get the width and height of the dragged object, so it automatically calculates it from the UI image. I do mention here that you do have 2 options. So if you subtracted the pointer position from the object position, then you need to add the offset to the pointer position during the drag. If you subtracted the object position from the pointer position, then you need to subtract the offset from the pointer position during the drag. You can tell, like if you click on it and it jumps, then you know you've got something backwards. You don't need to go back and check it. So let's go ahead and take a look at Unity. So here's Unity right here. I have the card right here, the card script. It's in Visual Studio. Yeah, so here's the card script right here. It's just one file. Was just showing, not much. We can go back, press play, and there it is. You can just click on it and move it around. I do have some debug output, card position, pointer press, pointer location. Yeah, it's pretty simple. I have all this in a canvas, and I have the card object as a child of the canvas, and the card is just a UI. As I mentioned over here, I set the pivot position to 0, 0 for X and Y. That's pretty simple. So yeah, I could actually use this to update the solitaire game to have a drag and drop interface. I made a couple other notes here. So if you're doing a card game or any type of game that you're dragging and dropping, you'll probably want to store the object's original position on drag start. In case that object or card is moved to an invalid position, then you can move it back. That's outside of this talk. One other thing you probably want to do is, like, whenever you hover over the object to be dragged, you can change the cursor to a hand or something like that, so you know that it's a a draggable card. I guess that doesn't matter as much if you're doing a mobile game because you really can't see the cursor anyway. But for a mouse-based game, you'll probably want to do that. You'll need to check whether the pointer is hovering on every frame and update if you do that. And if you need some more information on 2D collision detection, you can look at, I did a talk on that a while back for Knox game design. And you can also use that to detect if the cursor is a rectangle, whether two rectangles are overlapping or something like that. So the next example is MonoGame. MonoGame is also in C#. Here's the code right here. Yeah, I'll just point out that in the update we also have the 3 states. Left button is pressed, and previous state was not pressed. That means it was clicked. So in MonoGame, you kind of got to handle the click event yourself by keeping the previous mouse state and the current mouse state. In some game environments, you got to do that. If the left button is held down, then we're going to say pointer down, call pointer down with the position. If the current left button state is not pressed, then we call pointer up with X and Y position. So the same thing we did in Unity. We've got our draw method down here. Basically just using a sprite batch draw, and we have a card draw method. This is defined over here. Here's our draw right there. And then we have our constructor, which basically just sets the drag state to false and setting the width and height. I did scale down the card side a little bit. So we have our pointer pressed. We're going to check pressed. Pointer up. We're going to stop drag. Pointer down. If it is being dragged, then we're going to update the card position to the pointer position plus the drag offset. Here's our check pressed with our pointer position. Basically the same exact thing as in Unity. If those conditions are met, then we're going to start drag. Yeah, so here's the MonoGame example. So in this one, we do have 2 files, the game1.cs and the card.cs, all in C#. We've got our card object. Down here, we're going to load the card image. You just import the card image using the MGCB editor. Click on that over here, and it should start. So you can see where we imported the card right there. It's just a PNG file. Here's our update. Already talked about the pointer pressed and up and down methods. Yeah, this is basically all the same code that I previously mentioned. Look at the card. Basically what I showed on the slide right there. It's the code. Run this, and this is what it looks like in MonoGame. As I said, I kind of scaled down the size of the card a little bit just to give it a little bit of area to move around. So the next one we're going to look at is GameMaker. So it's pretty easy in GameMaker. You just have your card object, which you define the sprite, the width and height of your image that you're going to drag around, and you can use the interface to create your events. The create, the step basically just means every frame or every update. Left pressed, and then left released. The frame that the left button is clicked, and the frame the left button is released. So you can see over here, I got the create. We're just going to create a variable called isDrag. That is false. We're going to have an offset X and an offset Y. For our left press, we're going to set isDrag to tree. So this is the frame that it was pressed. We're going to set offset X to the X position of the card object minus the current mouse X. And we're going to set offset Y to the Y position of the object minus the current mouse Y position. And then on step, that's basically our update. If the card is being dragged, then we're going to set the X position to the mouse X plus the offset X. And we're going to set Y to the mouse Y plus offset Y. The other one is left released. So whenever it's released, we're just going to say isDrag equals false. So a couple of notes about GameMaker. No need to check for collision. It's handled by the left press event plus the sprite collision mask. So you don't have to actually do the math for that one. The step event works better than the left down. So there is like a left held down event, but I found out using step works better when dragging, because if you start moving the mouse sporadically around, then you can lose the object. I'm not sure why that is. Alternatively, you can actually just like check for all these yourself using the mouse check button method and step instead of using those mouse events. So if you can do it that way, or maybe a little bit better control. So here's GameMaker right here. So as I said, here's our create, step, left pressed, left released. Good right there. So if we run this, then here it is. I didn't scale this one down. That's why it looks bigger, but you can see I can click on it, move it around. I guess the reason I'm going over this, because this doesn't work out of the box. There's no drag and drop interface that I'm aware of. There may be libraries out there, but if you need to implement yourself, this is a good way to do it. I'll also mention, I think you can click on the card sprite, go find it under sprites. Card sprite, here it is. So here's the bounding box right here, collision mask. If you do need to change the size of the collision, you can go in here and edit it yourself. Automatic, yeah, manual. You can change the size of it. So one thing I didn't mention is like this image I'm using has rounded corners. So technically you could click in this upper one of the corners and still drag it. It isn't that perfect where it doesn't detect the clicks on the transparent edges. And the final example I'm doing for drag and drop is in SDL. Now, I haven't talked about SDL in a while, but I thought it'd be good to look at it again if you want to do C or C++. This is a good option to use. So SDL, it actually took me longer to set up the SDL environment than to like write this code and test it out, or it's about the same amount of time. But if you haven't done SDL in a while, or you're setting it up on a new computer, then there's a couple of tricks. I'm using MinGW64, and that was one of the issues I ran into. Is I was trying to get it running under 64-bit instead of 32, and by default, running the installer puts the 32-bit library. So you just got to make sure the bit mode of your compiler, your GCC, matches the libraries that you're using. So that's a trick you got to watch out for. So basically, I have a screen width and height. I went ahead and defined constants for true and false. Here's our structure. We got a card object right here. Same thing, but storing a SDL surface for the card image. Got the X and Y coordinate for the card, width and height, and then an int. Because C, I'm doing all this in just plain C. C doesn't have a Boolean, so I'm just doing that as an int, using 1 and 0 integers. Wasting a little bit of memory there for a bit, but I think it's okay just for this example. Then we're keeping track of our drag offset X and drag offset Y. I have those outside the actual card. I have some function prototypes here, setup card, destroy card, and check card pressed. All those take card objects, the card structure as parameters, and the card pressed takes the pointer X and pointer Y. Here's some SDL stuff. Here's our main entry point, the SDL setup, and I didn't add a lot of checking. I'll leave that as an exercise to the student. I just kind of wanted to keep this clean. But yeah, you really should have checks for null in here, especially around your SDL init. So we got our SDL window, our SDL surface for the screen, SDL init for the video, create our window object right here, our drag and drop SDL, passing the screen width and height, creating a screen surface right here using SDL get window surface, and then SDL update window surface right there. Here's where we're creating. So I went ahead and made it a pointer to a card structure. Made sure not to say object, but it's a pointer to a card structure. And in that case, you need to malloc the size of your card that you're creating. I did verify if you don't malloc that, then you will get a segmentation fault. You really should do a memory check around this. Make sure you did get the memory that you requested. Here's where we're passing our setup card. Setup card is over here at the bottom. So passing our card object. Load into the SDL, load BMP image for the card. I did have to take my card image, which was in GIMP, export that. I don't think in GIMP you can save as BMPs anymore. So I had to paste it into like MS Paint and then save the BMP that way. I don't know what was going on there. I don't know if they just removed BMPs totally from GIMP, or maybe I just overlooked it. I don't know. Set color key, that's saying yeah. So I had to set it to magenta for transparent color. That's what this is right here. All red, no green, all blue. Here's where we're setting up the values. I just put 3216 for initial X and Y coordinate for our card. Same width and height, 250 width, 350 height. Then we have our int is dragged, setting that to false, which is 0. Come back over here. Then got an SDL rect just for drawing it. I originally had this in the strut, then I took it out because it really didn't have anything to do with the card itself. It's just used for drawing it to the screen. Here's our pointer X and pointer Y. We're getting an SDL event every frame, so while true, really we should have a delay in this, but it's just going to keep spinning as fast as it can. Poll event, pass in the address of the event object. It's going to give us whatever event is currently on the queue, if there is an event. If the event is SDL quit, then we're just going to break out of this loop and quit. So I'm not sure if this is the best, but I'm calling SDL get mouse state every loop, getting the X and Y coordinate. I probably should have this down here in one of these if statements. It's like, well, do you call it once every loop or every? Yeah, I should probably have it in here. So if the event type is SDL mouse button down, we're just assuming it's the left mouse button. I don't think in SDL there's a way to check which button it is. I just didn't do that. So we're doing check card pressed, passing in the pointer X and Y and the card object. Check card pressed, same thing as we did in C#. This is just C. So it looks pretty much the same. Pointer X greater than or equal to card X, and pointer X less than card X plus card width. Pointer Y is greater than or equal to card Y, and pointer Y is less than card Y plus card height. If all that's true, if all four of those are true, then we're going to return true. Otherwise, we're going to return false. So that's for the mouse button is down. I think that's just the one frame that it is pressed. So if all that's true, then we're going to set card is drag to true. Then we're going to set our drag offset X and drag offset Y to the card position X minus pointer X and card position Y. We're going to set the drag offset Y to card position Y minus pointer Y. If the event type is SDL mouse button up, I believe that's the frame that it was released, and we're going to set card is drag is to false. Same thing we did in all the other ones. The other case is if the event is mouse motion, that just means the mouse has been moved. So it's a little bit different than mouse down. It's just if the mouse is being moved, but I don't think it gets called on like mouse button down. It doesn't get called every frame. It's only the frames when it gets moved. So a little bit different there. So if the card is dragged, if the boolean is true, or if the int is 1 for true, then we're going to set the card position X to the pointer X plus the drag offset X. We're going to set the cards Y to pointer Y plus drag offset Y. So this is just clearing the screen here using cornflower blue right there. And then we got a rect card blit, or just a blit object for drawing the card onto the screen surface. Just passing the card X, Y, width and height to that rectangle. So we're going to use that rect blit as a parameter to SDL blit surface. We're going to pass in the card's image, null, then the screen surface, and that rect blit card blit right there. And then we're going to update the Windows surface right there. And yeah, that's just going to keep running every as fast as it can. Really, like I said earlier, you should probably put a delay in there. So if you do have time at the end of the loop, you don't want to keep running the loop over and over again. Probably want to like set it to like 60 frames a second, or maybe even greater if you're doing VR or something like that. After this loop exit, we're going to destroy our card, and then we're going to destroy the window and call SDL quit and return it. So I got this running in MinGW64, which I hadn't done in the past. Usually I was using the 32-bit version, but I got the 64-bit version. And there is an SDL3 out now, but I didn't feel like learning it for this. Again, I'll have all the code for all of these posted in the online code repository. Like I got all the examples: GameMaker, MonoGame, SDL, and Unity. There, SDL. So here's the code. I did like put a simple little install.txt in here, kind of like a little README right there. This is what I had to do to get SDL, the installation of GCC, then download this from the SDL website, SDL2-devil-2.30.11-mingw-tar.gz. Make sure you get the mingw right there. Then you just untar it, CD into that directory. Then this is important. This is the one difference right here. You want to call make install package, and then you pass in this x86 64 MinGW, because by default it does the 32-bit libraries if you just do make native. Then CD into the demos or wherever you extracted the demos at, go to SDL, and then the full command is gcc-o, call it wherever you want to, drag and drop, then pass in your C file, drag and drop.c, then do a backtick, SDL2-config, --g flags, --libs, then backtick again. But I actually went in there and created a make file, which is always good for C programs. So you just have to call make, just call make, and it should work, or make drag and drop. And I have it for whenever the C or the object files are modified. I also have a test in there. So the first thing you probably want to do is make sure that GCC is working on like a simple little hello world files. But you can call make clean. That'll clean out any test files. I actually didn't clean out the drag and drop right there. I need to add that to the make file. rm drag and drop.exe. So you just call make right there, and it'll compile it for you. Yep, that's all there is to it. But yeah, I didn't get it working on my first time. It probably took me an hour or so, hour and a half to figure out the latest to get everything right, to get this to run. So yeah, just do dot forward. You probably just run the exe, but dragging dot forward dot drag and drop. Here it is. I didn't do any scaling or anything, but you can click on it, and so yeah, I didn't do any scaling or anything, but yeah, click on it. And if you click outside, it doesn't drag. If you click outside and click and it moves, then you know something went wrong. So watch out for that. Then the other thing is, like, you could actually drag this all the way off, and then you lose it forever. So really, there needs to be some balance checking. Like, don't let the player drag it so far off that you can't get it back. But yeah, you could use this to update solitaire game. Use this for a lot of different card games out there. I guess one other thing to think about is, like, if you are doing a card game like solitaire, just get the basic engine working first, like I did last month. Then you can go in and make the drag and drop a separate problem to solve, just using one card. Then once you get that like unit or component working, then you can add that into the main card game, the main solitaire game. That way you're not trying to figure out how to do drag and drop in your main card game engine. You just kind of make it a separate problem, then just merge it in. But yeah, it works pretty good. I'll probably do that when I get the chance. But anyway, thought this would be a short, quick talk, and also demonstrating a lot of different game development environments. I didn't do Godot, I didn't do Unreal Engine, just not enough time in the world to do everything. But it does show, I think we did before. So yeah, hopefully everybody out there found this useful. Appreciate everyone out there listening and watching, and I'll plan on being back in a month.